So for those of you who've decided to join us for this video, you're going to have one step up for your quiz. So notice this question. What they're going to ask you to do is drag the answer from this column into the box that would be the result of doing exponent laws. So we've done our exponent laws, and that law is not going to change just because the exponents of fractions. So if you look here, you've got fraction exponents. So your rules are going to stay the same. You're just going to now work with fraction rules. So take a look at this first one. Think about what I have here, okay? If I had this x to the 8th power cubed, right? That's what we did in class. We would distribute this 3 to the 8, and we'd multiply to get x to the 24th power. Well, this time, what I have is I have x to the 8th power raised to the 3rd fourths, 3/4, 3/4. So I'm going to go here. If you want to go do a sidebar on your piece of paper, I'm going to do 8 times 3/4. What happens is this 4 can cancel to a 1. This can cancel to a 2. So I end up with 6. So my answer on this one would be x to the 6th power. So do you see how we're going to be doing these? It doesn't change just because there's a fraction. Our exponent law still stays the same. Well, what about here? So if I had, let's just think about this. If I had x to the 2nd power times x to the 3rd power, I would do 2 plus 3, and I'd get 5. Notice the difference between this one and the first one. I'm adding because it's a product of powers. It's a product of powers because I am multiplying them. This was a power to a power. Okay? So the only thing that changes now in this problem is it's a fraction. So I'm still going to do 1/2 plus 1/3. Well, this is where you get your piece of paper and do a sidebar. What is 1/2 plus 1/3? Let's think about this. I need common denominators. So what I'm going to do is I'm going to rewrite each fraction with a denominator of 6. So I times this by 3. This gets times by 3 and 2. So really, my final answer is going to be x to the 5/6 power. So that's what you're going to do on this problem. I'm not going to go through all of it, but I want you to understand, don't freak out when you see a fraction exponent. We've told you, fractions are numbers. So now let's look here. So we know this was a struggle for some, and that's okay. It always is. So let's take a look first, before I do anything, at our two radicands. I can't add these. They're different, so I need to simplify. So we're going to need to do factor trees. So let's start with 18. If I break 18 down, I'm going to do 2 times 9. There are other factor pairs. This is just what I chose. And 9 breaks down to 3 times 3. So I put all those factors inside. 2 times 3 times 3. Okay? Let's finish simplifying this one off. My root here, remember, when you don't see a root, it's 2. That means I'm making pairs of 2. So what's going to happen is this 3 is going to come out. Everyone with me? And the 2 didn't have a partner, so it stays inside. Let's go do our 50, and we'll do it in a different color. So when I break down 50, I would have 2 times 25, and then 5 times 5. Again, let's put this inside a radical. There is no number here, so I'm assuming it's 2. So now what I'm going to do, I need a pair of 2's. So this 5 is going to come out this time, and a 2 still gets left behind. Now, these I can add. I can add these because their radicand's the same. So all I'm going to do, it's like combining like terms. 3 plus 5 is 8, and I write square root of 2. There it is.